So we're going to be dividing, hey, let's seriously, we're going to be dividing radicals today. So what we're checking for, just like when we were multiplying radicals, we have to check to make sure the indexes are the same. Indices is really the plural of index. We're checking to see if they're the same. If you look at the property in terms of A and B, you will see that, in fact, the index here and here are the same. They're both n. And we can write them underneath one big radical, if that's the case. So if I look at this particular example, I have a 3 as my index. They're both the same, which is a good thing, which means that I can rewrite this as one radical, 7 over 4x squared. Okay? Just combining. You can put them both underneath the same one, as long as the indexes are the same. Okay? And so that would be, in this case, option C. Hi, Louise. Put that on my desk for me, love. All right, so, because I guarantee his is excused. So, look at this particular problem. Beginning of class, I asked you to write it down. It's okay to write it this. Let's write this one down. They're both the same type of problem.
I didn't even write down the.
All right. Shh. So what we need to look at is I have a radical and a division problem. Two radicals, actually. I have a radical in the numerator, and I have a radical in the denominator. And what I want to do is reduce this and simplify it as much as I can. So I'm checking to make sure that my indices are the same. What is the index of both of these radicals? If it's not there, what do we assume it to be? A 2, right? It's a square root. So are they both the same? Yeah. Yes. So we know we can go ahead and write it all underneath 1. We keep the same numerator. We keep the same denominator. And we look to see, can I reduce what's underneath? Okay? So I can, and that's what I want to do. What is 50 divided by 2?
25.
There you go. And what do I do with the powers of x? When I have it as a fraction, just kind of over here off to the side, if I just want to reduce x to the 6th over x to the 4th, do you remember what we do with those exponents? I subtract them. Very good. Okay, so remember, if they were next to each other, I would be multiplying them, and I would not add those exponents, right? But when I'm dividing them, I end up subtracting. So 6 minus 4 is, so I know I just have x squared. There is nothing in the denominator anymore. It's just 1. I guess there is something. It's 1. But I don't have to write it as a fraction any longer. So now I'm just looking at my square root, and I want to simplify what's there. What's the square root of 25? 5. What's the square root of x squared? It's just x. If you want to think about it, x squared is just x times x. I'm looking for groups of 2. I have one group of 2 that I can bring out. There's nothing left underneath my radical. Okay? I don't have to worry about the absolute values in this case, Christian, because, or do I? The power has to be odd, right? Look back at the problem that we were doing before. Let me find it real quick. Here. Okay, we have an even index and an odd power. Let's see if that's the same case here. I have a even index, 2 is even, and I have an odd. So don't I have to do this? I do. Yeah. Okay. Okay, Eric. Because this index is even, 2 is even, and this power 1 is odd. So you have to put absolute. Okay. If the x was squared, we wouldn't have to worry about it. To the 3rd power, yes. Any odd, odd. Okay. All right, let's look at one more. This is really hard to see, so I'm going to try to make it a little bit bigger. All right. Got to divide those two. This one's a little different. Oh. Yeah, I just divided. And I just simplified. That's all. Divide, simplify. Because it's an odd power. 1 is odd number. In underneath the radical, but when I bring it out. When you have an even and an odd, you have to do that. It'd be left over on the inside. Yep, sure would. Good question, Shamar. So if you can do that and it simplifies under the radical, that's the way I want you to do it. Okay? If you look at the next problem here, the cube, I'll try to write a little bit bigger, the cubed root of 7x over the cubed root of 5y squared.
So are we going to get more?
This is the last thing we're going to, huh?
Will we get more perfect numbers?
I don't understand your question.
Like, are we going to get more perfect numbers working with dividing?
Not necessarily. Not necessarily. That just happened to be a coincidence, that one was.
So that was like 49. It'll be 7, right? The last question?
Yes. All right, so in this one, what would the benefit be to put them all underneath the same radical? Look at the question. Nothing. Because, does 7 over 5 reduce? No. Does x over y squared reduce? No. So putting them underneath one radical doesn't really make a lot of sense. In the last problem, it made a lot of sense because you could do that. But here, it doesn't really help us. The unfortunate part is that in math, we don't like to leave our answers with a radical in the denominator. So what we have to do is something called rationalize it. Rationalizing the denominator is a fancy way of saying getting rid of the radical in the denominator, and getting rid of the radical in the bottom of the fraction. Okay? So we need to figure out a way to do that. And what we're going to end up doing is multiplying both the top and the bottom by a specific number to get rid of the radical. Okay? That's the purpose of this. So, in the denominator, we want to be able to get rid of it. We want to be able to make this a perfect cube. Okay? How many additional y's would I need to make this a perfect cube? I have 2 right now under the radical. How many more would I need? Just 1 more. So what I'm going to do is I'm going to figure out what I'm going to multiply the top and the bottom by, because whatever I multiply, if I multiply the top by a number and the bottom by a number, won't it just be 1? Isn't anything over itself 1? All right. So we have the cube root. We have to have 1 additional y, right? So I'm going to put 1 y, now 1 y here, and I have to put 1 up here. I'm multiplying the top and the bottom by the same. Why did I do that? Because I want there to be how many y's down there? 3. So hang on. Not 3y. No. Hang on. How many 5s do I have right now in the denominator? How many do I need total in order to bring out a 5 of the, I need 2 additional 2 additional 5s. So I'm going to put 5 squared, which is 25, but we're going to leave it as 5 squared. Is that okay? So 5 squared and 5 squared.
So why is it y 5 squared?
It could be 5, it could be 25y. Okay, I'm going to start over. Everyone really, just listen. I'm trying to find a number or something to multiply both the numerator and the denominator by, because I'm trying to get rid of the radical. What I want to do is find what will be a perfect cube and what will make the denominator a perfect cube, which means I'm looking for groups of 3 of things because the index is 3. So right now I have 2 y's. If I had an additional y, wouldn't I have a total of 3? Then I could bring it out and there'd be no more radicals. That's my point. I have 1 5. I want a total of 3. So I'm going to multiply by a total of 2 more. Now, when I multiply these fractions, what's in the bottom? The radical is gone because I have 3 5s and 3 y's, right? I can bring one of each of those out, and I'm left with just a 5y in the denominator. Make sure you understand that. How many 5s do I have? Okay, anyway, there's a total of 3 5s and 3 y's. Remember this, if I had 5 to the third, y to the third, and this is the third, can't I bring out 1 5 and 1 y? Think about it. 5, 5, 5, got a group of 5s. Y, 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 got a group of y's. I brought one out for each, and there's nothing left over, so there's no more radical. Well, I'm dividing. I'm trying to figure, I can only handle one question at a time. So just hang on. I chose what I wrote in red on purpose. I picked it. I picked it because I wanted the denominator to go, the radical to go away. Okay? I have to decide for myself, and it will be different every time, what number to multiply the top and the bottom by. I picked this number because I'm looking for groups of 3, because of my index of 3, to pull out. Since I only had 1 5, I knew I needed 2 more to make a total of 3. I had 2 y's, I knew I needed 1 more for a total of 3. So now I brought out a total of 3, a total of 3. I brought 1 5 out, 1 y out. There's no more radical. I'm done. Okay? Okay. Let me go on to the top, and then we'll come back. Okay? In the top, can I multiply those? So I'm going to. Let me just erase the bottom here so we don't get too confused. I have the cubed root of 25 times 7. What is that? No. 25 times 7. 175. 5 squared. Right? 5 squared times 7. And then I have x times y. That's my answer, folks. How many 5s do I have in the bottom, Tim? 3. 2 and 1. So I brought out, I have 3 5s. So I brought them out. And then I have 3 y's. 2, 3. 3 y's. So I brought it out. Got me now? Okay.
Oh, but what about the x at the top?
What x's, baby?
You got an x.
Right, because I just multiplied the top and wrote it here. That's all I did. 7 times 5 squared is 175. X and y, I just wrote it.
Oh.
That's it. Who had a different question? Daniel. No, it says underneath. The only thing I can bring out is if it's grouped in pairs of 3. And it's just, I have 2 5s, but that's not enough to bring it out.
Right now.
All right, I think we should try another one. Okay? Let's just try. All right, are you ready? We're going to do the square root this time, okay, of 5x over the square root of 3y. Let's just do it that way. Let's make it simple. Okay? So that's it. Just try this one. I'm going to pause it for a minute. I want you to decide how to, first of all, does it make sense to put it underneath one big radical? Sometimes that does, so you want to check for that. But that doesn't make sense here because nothing's going to reduce. So try it by rationalizing the denominator. So since I'm looking for 2 of both the 3 and the y, because a group of 2 will make the radical go away. I'm just simply going to multiply by 1 additional square root of 3y. Yes, ma'am, Alexis. Shh. Are you sure? Gabby. Okay, let's see if we can answer Gabby's question. Why do I have to multiply the top as well? Because anything over itself is 1. I'm not trying to change the value of the expression. So this is just really 1. This times 1 doesn't change the value. So I have to do it to both the numerator and the denominator. Christian, shh. No.
What if, like, could you also do it so if you're looking for groups of 2, could you do, like, for this question, 3 squared or 3 cubed?
Yes, you could. You could do as many as you want, yes. But then you'll end, if you do it more than that, though, Christian, you'll end up having to reduce at the end.
So
you want to do it as little as possible. Okay? It's a good point, though. You could. Do you understand? Remember your question now? Shh. Okay. Go ahead and tell me what we do. What's left in the denominator? That's right. Just plain old 3y. The radical goes away. Good. And the numerator would be? Square root of? That's it. Done. High five. Up top, as my daughter says. Up top. All right. I know, right? Okay. So what we're going to do is I'm going to give you some problems to work on now.